Okay, dear students, welcome to our topic, that is dynamometer type wattmeter. Last class we have seen clearly the construction and working principle of moving coil instrument, moving iron instruments, and we compared few important aspects in between moving coil and moving iron instruments. So we have got some good idea what is these two instruments converted into ammeter and voltmeter in our electrical fields. Most of the voltmeters and ammeters are based on these two principles. Nowadays all analogometers are this one, and these are all replaced with the digital meters in future. But as electrical students we should know what is the basic operation of this thing. Now let us start our class, and this is regarding to third semester electrical and electronics engineering students. Our subject also electrical and electronics measuring instruments EE 304. Subtopic is the electromagnetic type dynamometer type wattmeter. Okay. Today objectives is the construction of dynamometer type instrument, its each and every part. After knowing the each part function, then the working principle of DM type wattmeter, then how this DM type instrument can be converted into ammeter to measure the current, converted into voltmeter to measure the voltage. That means the dynamometer type instrument can be used as a ammeter, voltmeter and wattmeters. The most of the wattmeters are dynamometer type wattmeters only. So let us see in details one by one. Have you remember this one? What is this one? I think you have used this wattmeter in secondary level in our laboratory to find SCOC test on a single phase transformer or calibration of dynamometer type wattmeter and phantom loading or normal resistive loading. This is the wattmeter. As we know that voltmeter will measure the voltage across the load, ammeter will measure the current in the circuit closed loop. So based on this one, voltmeter and ammeter product V into I, we are going to get the product that is called power. So P is equal to, what's the formula? So in case of the DC, so for example, if you are observing that, so here is a one bulb, okay. So now there is a one source. Now it is connected through some supply that is connected to this one here. Here I want to know the current. I connected the one ammeter. I want to connect one voltmeter across this one to measure the what is the voltage. Then what is happen? So if in case of the DC, if you connected the plus minus this one, then P is equal to V into I. Then V can be measured by connecting the voltmeter across the terminals, and I is the current in the circuit taken by the load from the supply. The product will give the power of how much power is taken by our incandescent lamp. Now it is okay. Power is equal V into I. For example, V is equal to 230 volts and current is equal to, for example, take the 1 ampere. So what is the power? 230 watts. Simple. Suppose you are connected this one AC. Second case. In this case, what will happen? In case of the AC, power is equal to V into I into cos phi. Power factor plays a role. Now let us, because here the load is the unity power factor, because resistive, the voltage and current are in phase, angle is 0. So thereby what will happen? The voltage and current in phase, power factor is a unity power factor, so it becomes to the one value, that is called V and I, same power here consumed in case of incandescent lamp if you are connected AC or DC as a input source. Okay. Now for example, I want connected, suppose same arrangement. Now I connecting here one load, the single phase fan, ceiling fan. So nature is the inductive load. So it will draw the current, always current is voltage, this one current has some angle lagging by some phi, that is equal, there is a power factor. Then so I connected the 1 ammeter, I connected the 1 voltmeter similar to this one, then applied and DC. Now what will happen? So here the power is equal, current will measure, the voltage will measure. So in case of the DC, it will give the power. Power is equal to V into I. Simple. Suppose in this case you are connected to the AC, because where is the frequency 50 Hz, that depend upon the L, that is called omega L, that is called 2 phi FL reactance. Then due to this one, the power factor is not unit power factor, it may be 0.85 power factor. Then what is the power? Power is equal to V into I into cos phi. So that means whatever the power here, this is called 1 in case of the DC. In this case, the 0.85, only 85% of the power is utilized here. That is the problem in case of the AC. So in this case, how we are going to 0.85 we are assumed here. Actually, what is the power factor of these lines in industry? So how to know it? So I want to know that power. In case of DC, I can multiply it simply voltmeter ammeter. But in case of the AC, how to connect? I want to connect the one other power factor meter in the circuit. So voltmeter reading and ammeter reading and power factor meter will give the total power. So I require the 3 meters to know the power in the AC circuits. Instead of using the 3 meters, I can use the only 1 meter. That meter is the watt meter. So single watt meter will measure current and voltage, and angle between the current and voltage will give the direct deflection on a calibrated scale. That is the beauty of wattmeter. Let us see how to use this wattmeter in our laboratories for measurement of power. The construction, its working principle already we have seen in previous classes. Now based on these advantages comparing to other moving iron and moving coil instrument, so it has a benefit. What are the advantages of dynamometer type instrument? So the scale is uniform because deflection torque is directly proportional to the theta, and it will give the accuracy results reading, and it can be used for AC applications as well as DC applications. At the same time, we are going to use it free from hysteresis and eddy current losses. So here we used the air coat, fixed coil and moving coil. At the same time, it has also some disadvantages. While using this dynamometer type wattmeter, at measurement of low power factor measurements, that is less than 0.5 power factor, the pressure coil causes some error while taking the readings. That is one disadvantage. That's why we required LPF wattmeters, UPF wattmeters separately in our laboratories. These type of the meters generally used in measurement of power in 3-phase induction motors. Under no load test on induction motors, we are going to use it LPF wattmeters. Under load condition, we are going to use the UPF wattmeters. At the same time, the torque, deflecting torque developed is very small, and this is a very low sensitive instrument. At the same time, the magnetic field produced inside is very weak. So screening is needed to avoid stray fields from outside. So that is a steel lining, already we have seen, required to avoid stray magnetic field enter or interfere with the already fixed coil and moving coil magnetic fields. These are the few advantages and disadvantages of dynamometer type wattmeters. This can be used as a voltmeter and it can be used as a ammeter. Now, as a wattmeter, we should remember how to connect this wattmeter in our laboratories. Sometimes the wattmeter contains more terminals. For example, ammeters, it has 3 terminals. One terminal is a common, another terminal is a 5 amperes, another terminal is a 10 amperes. For example, you take it here. For example, you take the one ammeter. Okay. Then this is a one ammeter. This is one terminal and this another terminal. Whatever input is connected, simply it will go to the output. Sometimes there is a possible to connect 3 terminals. One is a, for example, common, one is a 5 amperes, one is a 10 amperes. Then we are going to connect the one supply, the output, and we are going to connect to measure the current, we are going to connect the input 10 amperes. That means here we are going to measure by help of this one up to 10 amps we are going to measure it. Simple 5 amperes or 10 amperes. So no confusion here. Now for in case of the voltmeter, similarly we are going to use it same voltmeter also we are going to take it. This is a voltmeter reading V and terminals 1, 2, 3 we can use, for example 150 volts, 300 volts and here is a common point 0. That means you are connected here. So based on the voltage, whether 150 volts or 300 volts, we can use the voltmeter. So here no need to whether we are going to see the upper scale and bottom scale based on this value. Simple. But sometimes in case of the wattmeter, it has the terminals, 4 terminals. One is a CC coil, another is a PC coil. You have to remember. This is a wattmeter. Okay. So how to connect this one? You can see it. Here remember that ammeter has only two terminals, input and output. Voltmeter has only two terminals, input and output V, whereas our wattmeter has four terminals, these four terminals, and it has a same wattmeter. It will measure what is the current in amps, it measures voltage in volts, it will measure power in watts. Now simple, here in this case, so you are going to connect input here and output is taken out. Input is here, output is taken, but in this case we have the M, L, C, V. So this is the, or we can say the V. Four terminals we have it. What are those four terminals? Now if you are observing these four terminals here, so here you can see it, four terminals. That means we connected the one coil and we have the another coil having high resistance here. So this terminal is called this one, we can say this is a M, you connect the main supply, and L, this terminal is the this terminal. So these two terminals we can say is a CC coil, current coil connected in series, CC coil, whereas this is a PC coil. Then what is it? It contains the common terminal and V. So we can see is a common, this is a V. Now common terminal we have to, the M and C should be shorted in wattmeter while you are using wattmeter in any places. Remember that. Take a small wire, connect it, M and C, short it. That means here M and C shorted. So M is input supply, it is the input supply, and L is going to the load. So here is connected to the load. So for example, this is a load connected here. This is a phase, this is a neutral. Now this load, this is a load. Now whatever the load current IL will pass through the CC coil. So the CC coil having a thick copper wire, small number of turns. At the same time it has a very less resistance within it. Whereas in PC coil, same, whatever the PC coil is coming here, you can see it, the PC coil. So whatever the current is coming here, the current is also flowing here. Same current is going here, and some the current is going and entered is the moving coil, and resistance is connected to the another terminal here, and circuit is closed. That means, so M here, C is shorted, that is same voltage, and these are the parallel connected across the this supply, across the supply. So it is known as a pressure coil or voltage coil. So this voltage coil is a moving coil. So already we have seen it is made up of, what is that one? It is made up of a small diameter, a cross sectional area, and we have seen this is a coil. So placed in between, okay, and its supply is taken here, and here is the one piece fixed coil, and this is the another fixed coil, F1 and F2, and is connected here. This is a moving coil. So these coils are having the very thickness, the conductor itself thickness, because it has to carry the more current, whereas this coil has a very lean, only single one. So no need to draw the load current. So this turns very thickness, but number of turns are very less. N is maybe 10 turns for example. Whereas this is the thickness of the wire is very less as compared to this one, you can see it, and but it's the number of turns is more. So here 10 only, you can use the maybe 100 turns to produce the flux, required flux. More number of turns, cross section of the area is less, cross section of the area is more, and less number of turns. You have to remember that thing. Now, so this CC coil is equal to nothing but this and this, and this coil is nothing but this coil. Now, this is the CC coil, this is PC coil. So, here M and C shorted, L is connected to the load, and V is connected to the another volt terminal. It will measure the what is the voltage across this one. It will measure what is the current this one. Okay. So now how to measure this one? If you are seeing this one, the current which is flowing through the CC coil, the same sum of the current is flowing through the PC coil also, and here connected some load here, here we connected. Now S1, S2, S3, S4 switches. Now here supply is given, phase and neutral. When S1 is one switch is closed, then the current is passing through here, current is taking from the supply, and the current is coming CC coil. Here is a M, this is a L, this is a C, this is a B, and this produces the fixed flux. It is also flowing, circuit is closed, current is also flowing, it is also producing some flux. So interaction of these two fluxes, the deflecting torque is developed. The deflecting torque will show the reading pointer will move. Okay. Now if I connected another load in series, then what will happen? The current drawn from the supply by the load is increased. Then so more current will flows through the CC coil. Proportional, the deflecting torque increases. So here is the same constant. The current flowing through the PC coil is the pressure coil is same, voltage is the same, but CC coil current changes based on the load. Now further increases another load, then current further increases, then TD also increases. Such a way that we are going to connect in our laboratories. Simple. So you have to connect the M towards the main, L towards the load, C, M and C shorted, and V is connected to this one. This is a simple connection of wattmeter in a circuit to measure the power. 4 terminals. So how many terminals? 1, 2, 3, 4 terminals. Sometimes we are going to face wattmeter having the more terminals. You can see, suppose one wattmeter having this arrangement, 1, 2, 3, 4, 5, and there is a setting also there is provided here. Settings, current settings, and here this is a reading, and this is equal to W. Reading is, for example, from 0 to 3000 watts. Now same readings here, you are going to see it, M, L, C, V1 and V2, and inside you can see here these are 2 terminals. Okay, these are the 2 settings. This one, there it is as a clip, just like you can see the one clip, and there's a one clip just like this clip. Or we can connect these clips such a way that So you connect the one clip here, and this clip is connected to here. So here, just like is a high range, you can see the H type, high range, just like you can see the L range is the low range. If two clips are connected in parallel, then high range. If it is connected L, just like this single, is the low range. If you connect to the two, high range. If you connect to single, low range. Two are the left here. Remember it. What is the high? What is the H? So what is the helpful? Later we will learn that equation. Okay. This is the 1 wattmeter is given. Now, so what is the, if supply is given, how the supply is connected? Now we can see it, supply. I am going to give supply now. So M is connected to the supply, current is coming. L is going to the load. For example, here connected the one load, bulb I placed here, and it's connected just like neutral the phase. Okay, then bulb is connected here. Now M and C as usual, M and C as usual we are going to short circuit, and here V1 and V2, two voltage ranges here. One voltage is for example this is 150, this is equal to 300 range. Okay, so otherwise you can write it. This is a 300, this is a 500. This terminal is intended for the 500 volts, the intended for the 300 volts. Okay, for example, in case I want to measure the single phase power, single phase power. What is the single phase power? Maximum is the 250 volts. So I can connect this terminal V1 to the neutral directly, because 300, 250 is enough. I can choose the V1. Okay, suppose I want to connect to the 3-phase supply, 400 volts. I want to connect to the 400 volts. Then instead of V1, I connect to the, this is equal to V2. So here is a 500 range. So I connect to the 400 range. Less than 500, nothing will happen. So this is the arrangement. For the single phase, we are going to the V1. For the 3-phase, we are going to the V2. This is a arrangement. At the same time, if the one bulb is connected, the current is for example, taking the 4 amperes, 200 watts or 500 watts, 4 amps. So I can connect here. This range is at the time of the manufacture itself, low range, high range. High range is, for example, you take the 10 amps, and low range you take the 5 amperes. Suppose the bulb which is connected draws of 4 amperes, then I can connect this setting, current setting, or high level or low level. So here remember, you have to use your mind, use your common sense, because you want to take 4 liters of water in a 5 liters of mug, nothing will happen. Okay, so this is appropriate. Now here I want to measure the 4 amperes, 5 amperes is better. So you have to connect the low range. Its settings should be low range. You have to connect. So this is the, so this range you are going to connect low range. So clips is only single is enough. This is the common sense, because the current is 4 amperes, but you are so you have the 5 amperes range. This is the low range is enough. Okay, this is the systematic way. Then what will happen? Once switch is closed, bulb will glow, it draws a current. That indicated some value. So based on this one, so for a wattmeter is indicating the what is the power. Power is equal, for example, 300 watts is indicating the deflection. Is it 300 watts actually? Yes, it is showing the 300 watts by the deflection. So in first class we have seen that absolute instruments and secondary instruments. Where absolute instruments are, you are going to use in standard instruments, then true value will give deflection into meter constant. whereas secondary instruments directly give the deflection, as we have seen in previous class. Similarly, remember that in this case wattmeter there is a chances to confuse. So here instead of here connecting the 300, there is a possible to connect to the 400, because here we require the 300 kgs is required. Now because here 300 volt, this is a 230 volts single phase, 250 liters of the water is required. So here there is a 300 liters drum is enough. Sometimes some may be asked, sir, why can't I use the 500 liters of drum? Because the 250 is less than the 500. Okay, you can use it. Nothing will happen. But is seeing awkward. You want to drink tea, just 10 ml, or you can use 20 ml in a glass. Same 20 ml of tea, you can use this for the water mug also, or you can use a bucket also. What will happen? 20 ml cannot pour in a bucket, you cannot pour in a drum. Yes, obviously we can use it, but seeing somewhat awkward. So you at that time you have to use your common sense. So you want to use 250 volts, better to take plus or minus somewhat higher is a better suitable. Otherwise what will happen? Your shirt is suitable for you only. Your shirt is not suitable for your younger brother. Similarly here too. So is everything wrong? Nothing will wrong. So what will happen, sir? If connected, instead of 300 I connected the 500. Here the load is a 4 amperes. Instead of 4 amperes I connected high range 10 amperes. Anything problem? Nothing will give the problem. There is a possible confuse whether you are going to connect the 300 or 500, whether you are going to connect the low range or high range. So 4 chances you are going to make the mistake. So nothing will happen. You connect any chances. Whatever the deflection that will comes into, you have to multiply with the, it's a meter constant, that multiplication factor. Multiplication factor into the deflection will give the correct value, whether the person is connected 300, connected in 500, whether he connected low range, whether he connected the high range. Nothing will happen. So this is a one method you have to remember. While anywhere if you want to use a multi-range wattmeter in any place, the deflection into MF you have to calculate. Sir, how to calculate MF, sir? Then you can see it. Okay, so that's I want to know. Now here you can see, remember that. Now what is happened? Here just remember that. Here suppose a connected here, okay, so no need, so okay, then so here one wattmeter is connected, M, L, C and okay. Okay. Okay, M, L, C, 300, 600, okay, volts, ranges. Now here connected high range, low range. Now this is a wattmeter, 0 to 3000. Full scale reading, this we can the full scale reading. Now there is a load here connected. One load is connected here, another load is connected here, and another load is connected here. Okay. Now what is happened? I can take the two cases. First case, I can take the single phase supply. Here is the 250 volts. Okay, so here range is the 250 volts single phase. Now supply is connected to the M. Now what is I am going to connect it? So now I connect to the supply M. I connect to the terminal M, and M and C shorted, and single phase supply I am going to connect to the connect to the 300. Okay, now this is connected to the neutral. This is the phase. Okay, now this here, sorry, this is connected to the, okay, this is connected to L. This load is connected to the L, and here 300 is connected to the this V1 V2. Now V1 is connected to this neutral. Now what happened? You can see it. The whatever the current comes, that is entered M and C, the CC coil, that will goes to the load, and load is opened here. Now same current is flowing C, and C is connected to this one and is connected to this one. Circuit is closed. Then the current is flowing. No current is flowing here because switches are open. Here connected range low. So here the current setting, this is known as the current setting. This is the voltage current. Now I connected the low range. Two are connected here. First case 300 volts. Okay, 300 volts connected, low range. Second case 300 volt high range. Third case 600 low range, 600 high range. 4 cases I am going to calculate what is the multiplication factor of a meter. Okay, so then here what is happened? So we connected M, L, this is the connection diagram. Now I connected the one load here. Then once circuit is closed, the current is passing through the load current, and it will show us the what is the current. For example, take the current, it may be 2 amperes. Now close another switch, it will draw as a 4 amperes. So if you draw this one, it will draw as a 5 amperes. So it is designed for the 5 amperes and 10 amperes. Okay, if you added the some more load in the circuit, it draws the current 6 amperes, but here place at the current setting is only 5 amperes, then meter will burn. So if the current is less than 5 amperes, you have to low range. If current is more than 5 amperes, you are going to place the parallel, vertical, just like vertical, high range. Now in this case, the 3 loads below the 5 amperes only. Now what is the reading? Now it is showing the reading of nearly, so 300, it's showing the nearly 300 watts. Now do the MF calculations. What is showing? The reading W1 showing is the reading is the 300 watts on deflection, and is connected to the voltage V1 is equal to 300, and current L1 low range, that is equal 5 amperes, and full scale deflection, that is the total is the maximum on the meter is the 3000 watts only. Now based on this one, what is the actual value? So the actual value is equal to, so deflection into MF, multiplication factor. So what is the multiplication factor? MF multiplication factor is equal to voltage range. That means here, what is the range you taken here? Here whether 300 or 600, which you are going to connected. If you are connected to the 300, you put the 300. If you connect to the 600, you place the 600. That is the voltage range. This is known as the, okay, so Now this is a voltage range. So this area is a voltage range, this area is a current range. So here voltage range 300, 600, current range setting, current setting 5 amperes, 10 amperes. Now I am going to write it equation voltage range V, the range, voltage range into current setting. So current setting divided by full scale reading. Full scale reading. So this is the multiplication factor formula. You have to remember. Multiplication factor is equal to voltage range on the meter which you are connected and current setting. So on meter, which type of the setting you have done by full scale reading. Where is the full scale reading? So you can see this is a full scale reading here. This is known as the full scale reading. What is the reading? From 0 to 3000. Full scale reading. So some meters may be 1500, some meters may be 3000, some meters may be 5000. Whatever the value, that is a full scale. That means scale is at last position is a maximum 3000 here assumed. Now based on this one, now we are going to calculate. Now what is the MF now? MF is equal to, here what is happened? So MF is equal, we are going to take it. So voltage range, what is the range we are connected? Meters. So I connected the meters here, M, L, C, V1. Okay, this is the current setting, this one. Now M is connected, that is the here current, what is the voltage range? V range is connected with the 300 into current setting, low range. Low range how much? 5 amperes by full scale reading, how much? 3000 by 3000. So this is a multiplication factor. This is 0, 0, 0, 0. Okay. So what is the value? 30. So 3 ones are 3, 10 is 5 ones are 5. That is equal to 5 ones are 5 2s. 0.5 is the multiplication factor. Once again you can see it. So whatever the voltage range, V1 is connected to 300. That is a 300 terminals. You see the where you are connected. So I connected 300 only. Okay. So we connect it. That is equal to 300. Now current setting, low setting 5 amperes by full scale is 3000. So we are going to get that value is the 0.5. That means actually what is the value you have got it? 300 into MF. So what is the MF now? So 3000 into MF is equal 0.5. That is equal actually 150 watts only. This is the reading. 150 watts. Actually the deflection is showing the 3000. That's 300. But into MF we are going to calculate it 150 watts only. Okay. So this is a one case. Now for example in second case, if I connected here same formula, I am going to use it formula. So in this case, for example V range, instead of connected, some person is connected directly, instead of 300 he connected the 600. Okay, then what is the case? Now here you can take it. So V2 is equal to 600, same current L range, low range, full scale reflection 3000, and at that condition you may get the reading that is equal to, you are going to get it, that is the only 150 watts. Deflection is equal to, deflection we are going to get it, deflection is equal to, so that may be, so you are going to the 150 watts instead of 300 watts. Now it is a deflection showing 150 watts. Now what is the, it is a 150. Let us see what will happen. So apply the formula. 600, V voltage range 600, current setting is 5 amperes, by full scale is 3000. Okay, 2 zeros, 6 ones, 6 fives, 5 ones, 5 ones, 1 to 1, 1. What is the MF? MF is equal to 1. 1 into 150, 150. So that is the reading. Don't panic, because here you can observe one thing. What happened? So we calculated both. In this case. You can see it. One person is calculated. You got the 300 reading. One person got it the 150 watts. So finally, by multiplying, we are going to get the actual is a 150 watts only. Here 150 watts. So he has the nearby knowledge. He has no knowledge. That's why he connected. Nothing will happen, but you have to multiply with the multiplication factor. So you are going to get the same values. Okay. Suppose you do the one thing. So if your current changes, suppose this person, so you can see it. Suppose in this case, if this person taking instead of 5 amperes, taken 10 amperes, what will happen? So you simply substitute here. So what will happen? Instead of 300, he connected same, but instead of 5, he taken the high range. This is a 10 by full scale same reading. So we are going to get this one. What is the value? This is equal to 1. That means here MF is equal, in this case, MF is equal to 1. When, so voltage is a 300, current setting is a high range. At that condition, MF is equal to 1. For this person, you can see it. What he has taken? So he has taken the, what he has taken? So he has taken the 600, no? Okay. Now he has taken the 600 value only into, now current setting is taken the 10 amperes. High range is taken. So here is taken the 6, instead of 300, 600 taken, instead of 5 amperes, he taken the 10 amperes, nothing will happen, then full scale reading. So what is the value? You are going to get 3 zeros, 3 zeros, 3 ones are 3 twos are. That means MF is equal to 2. That means whatever the value you are going to get into 2, you are going to get the actual value. Okay. So these are the different confusion states. So don't confuse it. Whatever you are connected physically, you take our formula, substitute that values. Whether you are going connected 300 or 150 or 600, whatever the value, you see it. You may have some doubt, sir, how to know that whether the low range is the 5 amperes, high range is the 10 amperes. It is for constant for all meters? No. That's why, so while you are using any wattmeter, first you should see inside the wattmeter. There is a difference. So there is a 5 by 10. That means 5 amperes the low range, 10 amperes the 10 high range. Sometimes instead of this one, some range the 10 by 20. What is the low range? L means simple. Connect the two terminals. The terminals, the 4 terminals, clips are connected here only. It's a low range. Now this one. Suppose 20 range, the 4 clips are connected such a way that is connected here. High range. Then we are going to take the 20 amperes. Which tap you are going to setting this one? Whether you are going to a low setting, you are going to the high setting. Based on your own setting, you have to take it. That is called voltage into current setting. The current settings value is based on your setting only, not meter values. Whether 5 by 10, 5 is the less low range, 10 is the high range. Suppose another meter having the 10 by 20, 10 is the low range, 20 is the high range. Sometimes different values. So that's why you have to see inside the glass, we are going to get the correct ranges. Now these terminals easily appear here. Sometimes more terminals are low. M, L, C, this is a common. Here is a, for example, 150, 300 and 600. That means this wattmeter can be used for from 0 to 600. Suppose I want to measure the 120, I connect to the up to 150, we give the accurate reading. Suppose I want to measure 280, I will measure the above 150 and below 300 it will measures. I want 440 volts, so I can measure 600. So this is a wattmeter, generally multi-purpose wattmeter, generally used in our electrical fields. Dear students, remember that. How to calculate the multiplication factor. Okay, so you got the concept. So once again I will explain, you can see it. So multiplication, what is the multiplication factor? Multiplication factor is equal to voltage range into current setting by full scale reading. So everything is available in the meter only. Whether you are connected instead of 3 ranges, which range you are connected, whether 150 range or 300 range or 600 range. The ranges may be different for the different machines. We take the V1, V2, V3. So whatever the physically connected with wire, that is the range here you put it. Then here the current setting, whether setting is by appearance visible, whether it is connected single clip or double clips. Based on this one, whether you see it inside the glass, you are going to substitute this value. Then see the full scale reading, whether 375 or 1500 or 3000, whatever the last reading you give at the full scale reading. Then you are going to the EMF. So keep it MF aside, then use this wattmeter. Every time take the deflection. For example, deflection. So first reading, serial number 1, first reading it is a 300. Second reading it may be 600. Fourth reading is 800. So every time you are going to calculate this one, 300 into EMF, 600 into EMF and 900 into EMF. So you are going to get the true value. Deflection into this MF. This is the one common method of wattmeter uses in laboratories, because this wattmeter you are going to use in final year level, where in synchronous motors, where in 3-phase induction motors, load test and no load test and black road test and squirrel cage induction motor. And in laboratory also, your circuit laboratory, you are going to use this wattmeters. If wattmeters may be multi-ranges, how to use? Use it. Single range, no need to multiply factor. Simply whatever the 4 terminals, simply whatever the reading that will comes, that is the actual reading. If the ranges, voltage ranges are changes, current setting is changes, the multi-purpose, then we are going to calculate multiplication factor. Dear students, remember that this is the procedure for calculation of the multiplication factor. Sometimes there is they will calculate directly company itself multiplication factor at the other side of the box. So you can observe this is a 1 wattmeter and this is a wattmeter also having the cover. Here they will calculate the procedure of the wattmeter, MF. So you take the reading and if it is possible calculate the MF, otherwise you can see here MF. What is the MF? You will write it here, whether it is a 2 or whether it is a 4 or it is a 0.5, you will write it. So based on the voltage range, current ranges, you will write it. Take simply directly from this value, otherwise we calculate this value. Okay, so this is a one important thing you have to remember while using wattmeters in our laboratories. Okay, so this is the one thing you have to remember. Now what are the things otherwise? So this is now we have seen the wattmeter and how to use the wattmeter in real time, and what are the different multiplication factor methods and what are the advantages we have seen. Okay, so if you are having any doubts, we will see later.